What is up, everybody? Welcome back to my YouTube channel. Today we're going to take a closer look at a Java-based solution designed to address the challenges students face in deeply understanding core programming concepts. My client, Mr. Miscue's vision, prompted me to create a tool that breaks down these concepts into modular components. So let's dive into the code and understand how it works. Now, my first tool is all about multi-dimensional arrays, a crucial in my opinion but often rushed through concept. So let's walk through the code. So you can see that I've defined a class with a main method and a findTarget method. So in the main method, I initialized a specific example of a two-dimensional array, setting the target sum explicitly to 10. The program I did then records the start time in milliseconds, and I called the findTarget method to check for two pairs of elements in the array whose sum equal to the target of 10, recording the end time afterwards. So the result, indicating whether such pairs are found, is printed along with the elapsed time for method execution measured in milliseconds. In the findTarget method, which I designed for this specific array and target sum, basically I had to iterate two pairs of elements in the array using nested loops, checking for pairs whose sum matches the target, 10 in this case. If found, I printed the pairs and returned true, otherwise the code should return false. And if you look closely as well, you see a condition, and the condition x1 cannot equal x2 and y1 cannot equal y2 just ensures that the pairs are distinct. And you can also see x1, y1. Well, if you don't take math, that can be a little confusing, but basically they just represent the columns and rows in the array. Well, that's it for the breakdown of this code. Now if I run the code, it should return the pairs and the results, as well as the elapsed time of 0 milliseconds. So as you can see, this code is really efficient, and I'm pretty proud with that. And by running this program, students get their hands-on experience with multi-dimensional arrays, reinforcing their understanding of this foundational concept, really tailored to my client, Mr. Miscue. Now let's move on to my second tool, my more basic tool. It's a simple calculator for fundamental operations, but don't underestimate it. It didn't get its name, the Calcanilator, for no reason. But now let's look at the code works. So the code implements a basic interactive program that takes user input for two numbers, prompts the user to select a mathematical operation, performs the operation, and displays the results. The program utilizes the scanner class for input, and after welcoming the user and explaining the steps, the program prompts the user to input two numbers. Then the start time is recorded by using the system.currentTimeMillis function. To insert valid input, the program uses a loop that continues until the user selects a valid operation. The user is then presented with a menu of operations: addition, subtraction, multiplication, and division, and the program checks for valid integer input. If the input is valid, the chosen operation is performed using a switch statement, and the result is printed. In the case of division, a check is included to prevent division by 0. Finally, the program records the end time after a valid operation is selected, calculates the elapsed time, and prints it in milliseconds. Now if you run the code, as you can see, I'm greeted and it asks me to enter two numbers. Let me just enter 2 and 2. And we'll do a division, so let's choose 4. As you can see, the result is 1 and the elapsed time is 4,054 milliseconds. Now what if I enter a number with a denominator of 0? Let's see. So I'll enter the first number as 2 and the second number as 0, and I'll choose division. And as you can see, I cannot divide by 0, and it asks me to please enter different numbers. Now if you also look, you can see that I added a function which is the mechanism to clear the input buffer when the user provides invalid input, such as entering a non-integer when prompted to select a method of operation. Now it's simple, but this is crucial to prevent unwanted behavior and ensure that subsequent input is not affected by the incorrect input. Now that is it for writing the code. And as you can see, this calculator serves as a practical exercise, prompting students to consider both basic arithmetic and code efficiency. And you can see that, once again, the comments provide great guidance for deeper understanding. In conclusion, guys, these Java-based tools provide a hand-on, guided approach to learning core programming concepts. By breaking down complex ideas into smaller, more manageable components, students can gain a deeper understanding and apply these concepts more effectively in various scenarios like the one of my clients. Thank you for joining me on my channel. Make sure to subscribe, like, and even drop a comment if you want. I just hope that these tools prove valuable in your programming journey, whether it be now or even later. Well, that is it for me, guys. Have a good day, good night, wherever you are. Enjoy.